Hello everybody, welcome again in another video. In this video, we will discuss chapter 24, section 3 in survey physics. Firstly, we will explain how to get the electric field due to point charge using Gauss's law. To use Gauss's law, we have to choose a suitable Gaussian surface, which is a sphere in this case. As we mentioned that the flux equals the sum of integrals of E dot dA, which equals Q enclosed over epsilon naught. And since this is a sphere, then we can simplify the equation so it reaches E times 4 pi r square, which equals Q enclosed over epsilon naught. So we can easily say that E equals Q over 4 pi r square epsilon naught. Okay, let's talk about the electric field due to infinite line charge. As you mentioned before that we should choose a suitable Gaussian surface, which is in this case a cylinder. And as usual, we will work on Gauss's law, so the sum of integrals will be factorized into 3 integrals, with an integral for each face. And since that face 1 and face 2, the perpendicular makes an angle of 90 degrees with the electric field lines, so cosine 90 will equal 0, which cancels out the first and the second integral, so we are left with the third integral, which will be simplified to E integral dA equals Q over epsilon naught. And as we know previously, the linear charge density, which is symbolized by lambda, equals Q over I. So we can substitute Q by I times lambda, and the integral dA equals 2 pi r times L. Then we will reach the following form: E times 2 pi r L equals I lambda over E epsilon naught. So we can deduce that E equals lambda over 2 pi r epsilon naught, or 2k E lambda over R, since that k equals 1 over 4 pi E epsilon naught. Now we will talk about the electric field due to infinite surface charge, and the suitable Gaussian surface here is the cylinder. So as usual, we will begin with Gauss's law, so as shown we will have 3 integrals. So the third will be cancelled because it makes an angle of 90 degrees with the perpendicular of the area. So by simplifying the other 2 integrals, we will reach that 2EA equals Q over epsilon naught, and since that the surface charge density, which is symbolized by sigma, equals Q over A, therefore Q equals sigma A. So by substituting, we can deduce that 2EA equals sigma A over E epsilon naught. So E equals sigma over 2E epsilon naught. That's all we have for today. Thanks for watching.